Welcome back, everyone, and welcome. No, that was terrible.
So many welcomes. I tried too many welcomes. Try one less welcome.
So two's okay, just not three.
Yeah.
Welcome, everyone, to another episode of the Networking Podcast. Today, we are here with another episode of our new series that we're calling Best Effort, where we basically pick a random topic, ideally relating to networking. I mean, we've been good at that so far.
Yeah.
And we just shoot the shit about it. So today, I guess I get to bring the topic. That was the whole theme here, even though we kind of collabed a little bit on this one, just for those of you at home. So today we're talking about data modeling. I guess the history, where we started, where we are now, the do's, the don'ts, and the whys and the why nots, and the why gots, which we'll get to later.
Oh, wow. Nice.
You like that?
All right. I like that.
It's better the second time.
Right? I wonder who else caught that.
Yeah, we'll see. Well, they're going to get it by the end of the episode, I'm sure. So, I guess to start off with, we'll just set some context. So, we've basically come a long way in the networking industry with how we drive the network, specifically the schema, which is what we're talking about today, with how we drive the network. So I've got a few things I would like to cover, but I'll before I dig into my laying some knowledge down for you, because I got some notes.
Yeah, I'm excited.
Are you comfortable? We can talk about this. Are you intelligent enough to talk about this?
No, I'm not intelligent enough to talk about it, but I'm a good listener. But I think we should start off with just defining what a data model is and why it's important when we're talking about data models of network operating systems, and how we consume these models and what they have been historically, maybe. And I know we'll get into all of this as we're going through this, but maybe just start off with what is a data model and why is it important to the networking operating system and the networking industry. Right.
Okay. So I think there's three areas, and we're only going to cover one of them today, but they all kind of go hand in hand, and maybe give some context. So we basically have the interfaces that we use to talk to the network. So SNMP, CLI, I guess we have RESTconf, NetConf, GNMI now. That's not what we're talking about today, or at least maybe at the tail end, but we're not talking about interfaces per se. What we're talking about is the schema, the data structures that are sent over that interface. So that is really what we're talking about when we talk about the data model. We're talking about the schema of the system, how it is going to structure and lay out its data, how we can access it, where things live, all that good stuff.
So a BGP neighbor falls under the BGP context, which falls under the networking or routing context, which then falls under something else, right? Potentially.
Correct.
Okay. So that whole, what you may have traditionally used as CLI, so a CLI would have had built into it a data model of sorts, because you would go and configure router XYZ. That would be a data model from the CLI's perspective.
Yeah, for sure. Basically, the schema, how things are laid out in the system. So the CLI has its own kind of data model. Ideally, it's driven by an underlying data model, but I guess we can get to that in a little bit.
Yep.
But yeah, basically how a system is going to lay out its data. And I guess the important piece, and why this topic is interesting today, how it is going to expose that layout, that schema, for any of the northbound, management layers to interrogate, to interact with. And that's going to be kind of the center of this conversation today, I think.
Okay, that makes sense. So I guess historically, we had something like SNMP and MIBs defining some sort of data model for SNMP. So that's kind of where we all came from, I guess, or it's been kind of the standard. In fact, standard and still used a lot today.
Very ubiquitous with networks today, for sure. Yep.
Indeed.
Yeah, and that's a super good place to start. And most of my notes all relate to SNMP.
Okay.
So
let's hear it.
Yeah, let's
learn me.
Let's lay down some facts. So basically, everyone likes to throw stones at SNMP these days, right? It's kind of the thing we all like to poke fun at. It has served us quite well. I think it's done a great job, actually, of kind of at least remaining relevant over the years, but it has kind of hit its limits in terms of bulk data and the transport it's using and the way it describes the data that it is sending. And we'll get to the change there. And we're obviously alluding to the fact that we now have Yang. But I think it's worth us kind of stepping back and going through the evolution of SNMP. So I'll rattle off some facts and some tidbits that I found as I was kind of researching this. So SNMP has been around for a really, really long time. Like, I didn't realize just how long. It has been around for an insanely long time. It's older than me in its original form, right?
Wow.
So Simple Gateway Management Protocol, which was kind of like the precursor to SNMP v1, was released in 1987. How old were you in 1987?
I was 2 years old.
There you go. Were you thinking about how to manage networks back then?
Absolutely. I was born that way.
So that's where we kind of started. We then evolved to SNMP v1 in 1988, I want to say. So, we not that, it was like a year after SGMP. I guess SGMP had a lot of flaws. I didn't do a lot of research into SGMP. didn't think it would be super relevant for this podcast. SNMP v1, community-based. One of the big issues with SNMP v1, which I learned as I was researching this, and I should have known in all honesty, is that it only supported 32-bit counters, which, makes sense when you go back that far. We only had 32-bit operating systems and all that good stuff. So made sense, I guess. That was one of the big things that SNMP v2 brought in. So within SNMP v1, you couldn't even display the max speed of a 10 gig interface. Not that they had a lot of 10 gig interfaces back then.
I was going to say, not a huge issue back then, I don't think.
Yep, and I know based on when we've been trying to do data modeling, within our line of work, that they had ways around this by having an additional field that you would implicitly multiply or add a multiplier to infer the speed of an interface.
Yeah.
So I think it's called like IF high speed or something. Someone can correct me what the actual name of the MIB/OID is. So we had ways around it, but there was a pretty big drawback. Like if you can imagine you have statistics on an interface and you have a counter that is incrementing. 32 bits on an interface is not a lot. No, maybe back then it was. But certainly at the speed of interfaces today, that's no bueno, right? So moving on from that, we brought in SNMP v2. What I didn't realize is that both, there was actually a v2 and a v2c. V2 tried to kind of create an uphaul on the security model that was used with SNMP, because that was seen as one of the issues with SNMP v1. Yeah. And it was kind of thrown away. I didn't look into exactly what it was, but it was party-based security.
Okay.
I don't know if you know anything about party-based security. I certainly don't.
Nothing. Absolutely.
But I can tell you the industry hated it. They were like, no.
Way to go,
no
industry.
Good.
Way to go. I support you, industry. I have no idea what, but I support that decision.
Yeah. So we ended up with the SNMP v2c, which was the one that actually really did take off. And I would say that is the most predominant SNMP we're going to see in networks today. Yeah. And that it's still community-based, just like SNMP v1 was, but they added a lot of performance increases to it. They allowed you to do get bulk, for example, instead of get next. Yeah. So you could retrieve a lot more data. And that's kind of where we were lived. That was in 1993, by the way, SNMP v2.
Holy smokes.
I know. You feeling old?
It's crazy.
Even I'm feeling old. So moving on from that.
I'm just feeling how old SNMP really is.
I mean, it's been around really long time.
Yeah.
So SNMP v3 came around 2002. That's when I saw most of the RFCs come about and get published. Of course, there was a huge uphaul on the security side of this. I guess, SNMP v2's attempt at party-based security, that got thrown away, but they introduced this whole USM model, or what does USM stand for? User Security Management or something?
Something like that, yeah.
Something like that. Introduced SNMP engine IDs to try and actually do validation of SNMP endpoints to make sure they were real. And of course, that was used to encode data. So you needed to know the engine ID of the far end. I remember, just a little anecdote, running networks back in New Zealand, and we had moved to SNMP v3, and to replace a system, so to replace like a small switch out at a cell site or something like that, when you're using v3, you had to encode the engine ID of that system in the new system in order for it to bring it on management. Otherwise, you had to onboard everything again. You basically had to treat it like a new system. You couldn't just push down the old configuration nicely. Right. You almost had to impersonate the old system. So certainly a bunch of issues here. They also brought in VACM, or the View-Based Access Management, I want to say. Okay. I just wrote down the acronyms.
Sounds pretty good.
I'm guessing
Sounds pretty good.
And really what this was the ability to have kind of fine-grained permissions at various points in the SNMP tree. And that That was pretty cool. Also, I didn't know this, but they introduced a bunch of new transports with SNMP v3. So I'd always thought that SNMP was pretty much purely UDP based, right? In fact, that was one of the things I was going to throw stones at in this episode was UDP is bad when you're trying to rely on it to understand the state of the network. But they actually brought about like SSH transport and even providing some transport security with TLS. So they actually improved a lot. Yeah, I didn't know any of this. Like I learned this an hour ago when I was kind of researching this.
Here's a question for you on SNMP. How much do you think SNMP was used for retrieval of data and monitoring versus configuration? Like from my perspective, of course, if you had large management systems, a lot of the configuration was done via SNMP. But if you as a whole, as like an industry, I don't think SNMP was used as much for configuring as it was for monitoring and receiving, either retrieving bulk data or data at all with gets or the equivalent, or just receiving traps, like from a monitoring standpoint. And I feel like SNMP really hit its stride when it was like in that field of monitoring and retrieving data versus the configuration side, which of course it could do, and was used heavily by a lot of very large management platforms. But I don't know. I feel like what are your thoughts around that? Do you feel like
No, I agree. I absolutely agree. I mean, I'm sure there's people that will throw stones at us for saying that, and there's a bunch of SNMP set happening out there, right? Like, don't get us wrong.
Yeah, no, exactly. I'm not saying it wasn't used. I'm just saying the ratio of monitoring versus configuring. I think monitoring was much more widely. Leveraged. SNMP was more widely leveraged.
How we used to build networks was we would configure it using CLI. So we'd like go and I'd have my little Excel template sitting on my lap. I'll plug in all my data, and then I would just copy and paste configuration.
Your little Perl script that generated.
Absolutely.
Exactly. Yeah. And exactly. It generated CLI and you push that down. Yeah. But then you would use SNMP for monitoring, right?
Exactly.
So it feels like it left kind of a gap, even though you did have this data model and you did have this way of setting the data, it wasn't used that way.
Yeah, and you highlight a good point that I didn't have noted down, but I think is absolutely valid when you consider the configuration aspect. When you are doing configuration through SNMP, there's no real way to configure a data structure and its underlying children at the same time, because you're really just setting individual OIDs, right? And
exactly.
I when you like look at this like Yang-driven model world, that is a lot different today, where you can set from a node and define the entire data structure from that node and all of its children, and you could define an entire service instance in one foul swoop, right?
Yeah.
So I didn't have that noted down, but that's a really good point.
But I think that's also what drove kind of the evolution to some more. And we'll get to it, I guess, to something like netconf Yang, which was, more focused on the configuration standpoint and less focused on the monitoring standpoint.
Yeah.
I'm not too sure where you are in your research and when we're going to get to netconf Yang, but it seems like we're
getting there.
To drop us on SNMP.
And we did say we weren't going to talk about interfaces, and we've spent this whole time talking about SNMP, which is an interface. But really what we're talking about is the underlying schema underneath it, right? Like the whole MIB and OID infrastructure and how that needed to change. The other things I have known, we're segueing into kind of the Yang side of things now, I think, and why something needed to change is, there was actually a data modeling language for SNMP called Structured Management Information, or SMI, and I think there was two versions of it. Most of the MIBs these days use version 2, but the amount of kind of data types they support, especially when you're trying to model kind of more complex data structures, not just like integers, whether they be 32 bits or 64 bits or signed or unsigned, or strings or maybe time ticks, counters, things like that. Like when you're really starting to like, what if you want to model an IP address and you wanted to model it as something other than a string, Yeah. You end up in kind of these weird states where you end up just modeling everything as a string, which really does limit your ability to embed a lot of that kind of validation or like, all the syntax magic we can do with Yang these days. Any kind of like range validation, like what if you only wanted to accept, values between 0 and 1? There's no way for you to embed that within the data model. You'd have to do that in some kind of back-end validation, whatever is receiving that set
so
instruction.
Like constraints or like a lack of constraints and being able to
exactly
put constraints on your data model. Yeah.
Yeah. So I think these are what led us to kind of reconsider things, right? And now we are 100% segued into the kind of new age of data modeling, which, as we all know, is Yang. What is interesting is the application world kind of went another way in how they were going to like model things using YAML predominantly.
YAML, yeah.
Yeah. And I don't know if that's worth talking about too much. There's differences between the two, of course. I think Yang is probably better at enforcing a lot of those constraints that I was talking about. Without having a backend try to interpret what those constraints mean. Because you can model all of this in YAML, right? But
which people do. Like if you start using Ansible, there's a lot of Ansible modules where you actually do model your configuration, your switch configuration, your router configuration in YAML. But then you have a module that converts that into whatever the actual data model that the operating system understands, which is mostly not built off of YAML.
Exactly. So I think we're getting to kind of why Yang is kind of utopia for network operators, for network engineers, for architects, anyone who's trying to build the automation layer that sits on top of the network. In that, for one, we mentioned WiGOT in the open, so we'll just talk about that really quickly. WiGOT is the Yango Toolkit, and basically it provides a suite of utilities to allow you to ingest, to kind of compile, or to model as protobufs. Any kind of Yang model, whether it be one provided by a vendor, one provided by a community, and we'll get to those in a little bit too. So there's a bunch of kind of automation and I'd say orchestration, programmatic interpretation of Yang data models, whereas it's not that there weren't compilers for SNMP, right? In looking this up, we found one from Erlang. I'm sure there's like Python SNMP compilers, so they existed, but really your ability to embed all your information in that schema and not rely on your application to understand it is one of the big differentiators. I think we kind of required us to move to a better way in Yang.
A better way, right. That makes sense, yeah. I'd agree.
Yeah, all right. You don't disagree. That's terrible. I don't think we're going to disagree much on this one, honestly.
No, I don't think so. Well, there's not much to disagree on most of this. I mean, the evolution from MIBs and SNMP to Yang with whatever other transport you're using, which I guess originally was netconf. I mean, that was kind of the big deal, right? When Yang came about to model your data, your network operating system data, netconf was also the protocol that was in parallel, kind of built to transport that. Yeah,
classic network engineers to be like,
exactly.
We need to build a new interface. You know what? Let's just stick it on top of something else. And for those of you who don't know, netconf is built on top of SSH. So using SSH as the transport, as the authentication mechanism, and I guess using all of that for your encryption, and then just relying on Yang for your data modeling, and exposing some methods to do like gets and sets and notifications and things like that. So
and what's the encoding for netconf XML, right?
It is
JSON.
Yeah. XML. Yep. So I guess, and we're going to get to the where we're at right now, which, I'm sure in 5 years' time, people are going to be listening to this and be like, these guys, they don't know what they're talking about. These days, we've got XYZ interface, and it's so much better.
yeah, clearly.
I'm sure that is likely going to happen, but I mean, I saw netconf as being kind of this way for us to adopt data modeling. And without doing a full upheaval in the network, right? Like we didn't have to, onboard gRPC at the time. We just had to, we all had SSH already. So everyone understood it. Everyone knew how to debug it. So there's a bunch of muscle memory and, industry knowledge that we could leverage with that. So yeah, we've gone through netconf. Well, I shouldn't say we've gone through. There's a lot of netconf deployments and it's still actively being developed.
It's still very widely used, But also with netconf, and I love how we started off this conversation, talking about how we won't talk about interfaces, but we've mostly talked about interfaces. But netconf, one thing that netconf brought to the table too was an enhanced set of RPCs, right?
Yes.
Versus SNMP, and then more structure around RPCs and what you can do with them.
Yep.
Which actually have carried forward even into GNMI, right? I mean, a lot of the RPCs are the same or similar. So that's what another thing that netconf brought to the table, beyond just being able to leverage something like Yang as a data model and transporting Yang and transporting that data model across over something, as you said, that already existed, SSH. It actually just provided also a set of more enhanced RPCs, I guess.
And we like enhanced RPCs. They're good for us.
Yeah. Definitely.
Yeah, so maybe there's a bunch of other interfaces as well, right? RESTconf, which is kind of trimmed down, runs over HTTP, still uses data modeling in a lot of cases, though it doesn't really have to in theory, but in a lot of cases it does. And then we have vendor APIs. So let's spend a little bit on vendor APIs because they can be model driven. In some cases, they're not. In some cases, I guess the schema of a database is kind of the model. A little bit.
That would be a model, I guess. Yeah.
But certainly the model is not defined in Yang. That is the distinction here. In a lot of cases. In some cases it is, of course.
And what would be the drawback? I mean, I guess if we go back to the modeling in Yang, and you touched upon it a little bit with YGOT, one of the advantages of being modeled in Yang is that the capability of building those bindings to whatever language you want. Maybe you're converting into Protos, but maybe you're also converting it to Python bindings or Go bindings of sorts or modules. With an API, I mean, in comparison to an API, that's not...
You can't.
Right,
yeah.
You can't, right?
Yeah.
And especially if it's not model driven at all.
Yeah, so the whole idea of using... industry momentum really matters when it comes to these kind of things, right? Like this is why YAML is so successful. It could have been any other kind of markup language, right? It's where the industry starts to follow. And eventually if you get like that critical mass and you start snowballing, and this is exactly what's happened with Yang, it's what happened with YAML in the application world. So all of the operators or anyone who's trying to consume these data models benefits from all this tooling that has been built by people who have already kind of walked the path you're trying to walk, right? And have figured out that, okay, I need a way to consume these data models programmatically. And why would I want to do that? Well, I'm getting tired of having to go and manually change my code every time someone adds a leaf somewhere or, changes a few fields around. And the whole idea that you can do this all programmatically, and you and I geek out on CI/CD pipelines and the ability to like compile this in and do validation before you push anything down to the network. All of that is really, you could do that with any data model, right? In theory.
Yeah.
But the whole community, the whole industry has kind of coalesced around Yang and have really started to build the tooling around it, which is why I think it's really hard for it to be kind of dethroned as the king of data modeling in the network world for that reason. Yeah.
Agreed.
Yeah. And as someone who has, built an operating system that is based on data modeling, there's so much just free stuff you get. Like, I remember how we used to have to do validation. Someone parses a value, like validating user input is a classic example, right? You'd used to have to encode the validation of that input somewhere, whether it be in the back end or the front end. It has to be somewhere. And more often than not, it would end up in the back end. So you had this problem where you were, I guess for one, it's just error prone. There's also the whole issue with people being able to manipulate and do injections and all that kind of stuff. But having kind of the single source of truth, not only for defining the schema itself, as in like how is data structured, but also the constraints for what inputs am I going to accept, and the whole being able to trigger things to whether or not they're read-only or read-write. SNMP's been doing that for a long time, so not a differentiator per se, but the ability to do all that within the data model and then to just enforce the data model within your application. And to have all of these kind of northbound interfaces just compile the data model and know immediately, like they know what input you're expecting based on the data model, which is it's amazing, right?
It's basically like a contract, right?
Yeah, exactly.
Between client and
very,
server,
very
you have
good
like
term.
you have a contract and you have to adhere to the contract. And if you go out of contract, then it'll stop you, right?
Yeah, exactly. So, I mean, you and I are clearly Yang fanboys. We should really have someone on who's an SNMP fanboy, and if their argument consists of anything outside of, well, but everybody has it and it already works, then I would be very surprised.
Yeah, basically.
We don't seem to be there's not very many drawbacks to moving to a Yang-based data model, right?
Yeah, if you take a step back and compare them, to me, there's no comparison. Yang is the way to go. If the only arguments you would possibly make is historic arguments, like, well, we've been using it and it's been working well, and we've been using it for 20 whatever years, and it serves its purpose, then we should keep using it. That would be the only reason the only thing you could say to it, right?
Yeah, I mean, I
don't
think
know.
so.
I can't think of any. I can't think of any positive anything else. If you took them side by side and said you had the decision to start from scratch, and you could either use MIBS plus SNMP or Yang plus pick your transport. A bit of a no-brainer in my opinion, but
Yeah.
happy to have people comment and correct us though. If there's like valid reasons as to why you should use SNMP, if you could start with a blank slate and MIBS, then I'm happy to hear them.
Yeah, I mean, me too. I can't think of any.
No.
Another thing, this was a random anecdote I came across while I was researching that, and it was mainly around the 32-bit, 64-bit thing. It was around how much data actually fits into 64 bits, and it is like insane, right? You could run the kind of anecdote I found is you could run a 1.6 tera interface, which doesn't exist yet, of course, but assuming we get them at some point, you could run that thing at line rate for 133 days. and count the bits before the 64-bit counter rolls. I mean, that's just insane. Absolutely insane. All right. So Yang good, SNMP and OIDs and MIBS bad. I think that's the general consensus here. Let's move on then. So I don't think we want to go into the do's and do nots of the interfaces themselves, although that was kind of the basis for talking about our data models. What I would like to talk about is the versions of those data models within Yang. So the obvious one being OpenConfig. And of course, we have all the vendor models. And I wrote down a bunch of stuff on OpenConfig, but before I kind of dive into just the process for how you contribute to OpenConfig and maybe some issues with that, but I see a lot of pros in it too, the more I kind of dig into it. Have you got anything more to talk about SNMP versus Yang?
No, I don't. I was going to jump into the OpenConfig, so I got nothing else.
Go ahead.
No, I was just going to say that before you even get into OpenConfig and the different Yang models, maybe we should discuss how these get interpreted on your traditional network operating systems. So a network operating system has, if you're a network engineer, you've been doing this for a while, you're super familiar with logging into a CLI, and that's your hands-on knowledge of a data model, because that's what you're exposed to is a CLI data model. And then now you're asked to do some network automation, and you start looking into that, and you're exposed to Yang and binding Yang into whatever programming language you want, and be able to build objects within that using Yang, which is all great. But who defines this mapping between Yang and what actually happens on the device, and who gives you these Yang models? Is it like a network operating system is going to then ship Yang models to you with like kind of like MIBS, like they're going to have a Yang zip, yang.zip, and with every release they're going to ship them to you, and then you have to basically parse that, and then how do you compare that to what you know on the CLI? Is it usually one-to-one?
Okay. I think that the answer is it depends, right? It depends kind of based on the history of that network operating system. I mean, and again, we'll go into Utopia. We'll talk about Greenfield for a second, because I think that's a good place to start. If you're building a network operating system today and you have to define the schema of the applications or kind of like your protocol daemons, the right way to do that is to define it in the same schema that you're going to expose northbound, for a lot of reasons. One being like just general performance. You don't have that tax of translating data between different structure types. The other just being visibility. And then the third just being having one single way to navigate and kind of manipulate the system. So, there's a lot of model-driven CLIs now. I think that is absolutely the utopia, where if you're building from scratch, the underlying schema should be the same data model that you're using northbound. And to your point, yes, you absolutely end up with a yang.zip or some other kind of compressed format of, here's our operating system and here are the data models that we support. And then you can then take those, they're like, they're written in Yang, and you can take those and run them through whatever compiler you want, create any bindings you want, and then, that goes into your CI/CD pipeline. So that's definitely the way you consume them. I don't think has really changed, in the sense that, in the old days, people shipped around MIBS, which did that whole kind of like OID mapping I was going to say nonsense there for a second, but let's not say that. These days, you'll get a set of data models that are supported with that operating system. So that much hasn't changed. I think in terms of how you interact with the system, I mean, it's a really interesting topic. We could spend a long time on this, but I'll try and summarize at least my thoughts on this, which are, if you have greenfield, you should always be interacting with the data model, always. It's the only way to drive that muscle memory. So, your whole show IP int brief. Let's just take that as an example. That really should be showing the IP interface data model. Now, that's not a real data model, so that's a problem, right? Like we're already found an issue with this whole utopia. I think the more and more you embed or don't try and hide the underlying schema to people that are kind of interrogating and using the system should look the same no matter what API you come in. APIs should really be chosen based on the merits of those APIs. If you're trying to do streaming telemetry, use an interface like GNMI or maybe netconf. If you're a human that's coming into the system, don't use a GNMI interface. Use a proper CLI interface. And
that's what it's designed for. Yeah.
That's what it's designed for. But the underlying schema in Utopia should be the same.
Right.
At least that's my thought. Now, that's not reality
so is the
in a lot of cases.
Is the expectation then that my network operating system vendor or my whatever network operating system I've chosen nowadays should have a pretty comprehensive Yang model that covers the very large majority of the feature set available on the device?
I love
because again, if you come back to like CLI is like your and it has been like your source of truth, right? It's always been if you can do anything on a router or switch, you do it in CLI. I mean, that is the one place you can go and do absolutely everything. And then as we introduce these interfaces and these models, obviously, again, utopian world is, like you said, you everything's driven off those models. Therefore, everything is accessible in the CLI that's accessible in every other northbound interface that you have to you. But that may not be, ideal today. But from your experience or knowledge, I guess, are most network operating system and vendors shipping Yang models that cover all or the very large majority of their capabilities?
So right now,
and the reason I ask is because we're going to get into OpenConfig, and that adds to me another layer of this particular issue, which is now you're going to have a model defined by the community, and then you have to have your vendors or your network operating system builders implement that model somehow, right? And then now you're going to have yet another discrepancy between what you expect a switch and a router to be able to be configured using this model versus what's reality, right? So I'm just don't know where we are in the industry. I mean, I do know a little bit, I guess, but I just want to get your take on it. where you feel the industry is with mapping and their Yang modeling versus what you can actually do on a switch and router.
I think we are kind of at that almost inflection point where the answer to this question a year ago would be very different than it is today, right? And also it's probably very different than it will be in 12 months' time. Right now, I would say the vast majority of operating systems have a data model available.
In Yang.
Now, in Yang, yeah.
Right.
Now, whether or not those are a superset or a subset of the available fields, I think the likely answer is that they're a subset today, right?
Yeah.
Like we are in we're still in that catch-up mode where every NOS vendor has had their own like internal proprietary schema. It's never been exposed, and they've just done translations. Some people just modeled it as a database. Some people modeled it using SNMP, like that's a thing. Mm-hmm. And some people actually kind of modeled it using something akin to Yang, but not Yang.
Right.
So the kind of adoption of Yang and moving things over is happening. Probably not as fast as we'd all like, for sure. But I think it is definitely happening. And certainly in the last 12, 24 months, I think the entire industry across all vendors has come a very, very long way because everyone is kind of in agreement, right? That this is the path forward. There's no real resistance to it anymore. Maybe there's some resistance to the actual structure of that data model. And I guess that's the whole OpenConfig conversation. Mm-hmm. But certainly modeling things in Yang and exposing them through model-driven interfaces is a fairly accepted path forwards within the industry today. Now, I would say in terms of what you can see in the CLI versus what you can do through a data model, there's still there's a big disparity there, right? Across a lot of NOS vendors. I think there's potentially some, that translation I talked about from the internal schema to a proper data model, it's not really that simple, right? Depending on how you model things and whether or not something like a show command is plucking from a bunch of different data models.
Which it would be. I mean, I would say the large majority of show commands are plucking from different data models.
Yeah. So that all introduces complexity, right? So yeah, we're not there yet. I think that is the answer I would give. I think the kind of snowball effect that we were talking about within the industry we're absolutely there. It's fairly well accepted that we need to adopt model-driven interfaces. We're trying to do more and more with automation. And the only way to do that and to be able to scale it from a maintenance perspective over time is to model things properly with Yang.
Right.
I mean, do you agree with that? Would that be your interpretation as well?
I think so. I mean, I think ideally that's true. I wonder if that's...
Ideally that's true?
Well, no, that is true. Sorry. I don't know where we are. I don't know where we are because there are a bunch of vendors who provide APIs, like a RESTful API, and not necessarily with associated Yang models to go with it. And people are happy to use those. And then there's also all these different other automation tool sets that aim at standardizing data models but aren't using Yang. They just use their own data models. So yeah, I think ideally that's where we end up. And it seems to me like there's a trend that we should be using Yang to do this, and it should be every network operating system should ship Yang models with their versions. I just don't know how much that's actually being used today and how much there is comparison between what's available in Yang and what's available in the operating system.
Yeah, I mean, I wouldn't say it's exactly a chicken egg scenario, but people won't consume the data models until they're rich enough to consume, right?
Exactly.
So I do think vendors starting to take a serious investment in modeling things using Yang, exposing those data models using standardized interfaces, all the ones we've mentioned. I think that is definitely what has to happen first. Once that does happen, and I'd say we're almost there, right? Like we're at the point now that if you're trying to do relatively simple operations, let's say you're trying to configure an interface or a sub-interface, or you're trying to build a network instance, these are all things you can probably do using a data model with the vast majority of, let's call them mainstream NOS vendors today. Like that's something you can do. So that's the start. I think once what you can see and you can configure and you can stream, right, out of these devices using Yang, once that gets more and more rich, we'll see more and more adoption outside of just the NOS itself, where these automation frameworks now start to adopt data modeling, and we've seen that, right? Like there's kind of GNMI plugins for a bunch of like time series database, like Telegraph. You and I messed around with Telegraph GNMI plugins a while back, so. Yeah, I think we're definitely at that kind of inflection point, but I think we're probably on just the other side of it right now, where things are kind of mainstream now, and the NOS vendors have kind of, let's say, the first, or there's been a couple of drops of NOS releases that have data modeling support and have support for these interfaces. Now that that's happened, I think that'll be the first wave of, okay, all these automation frameworks, they're not going to consume SNMP anymore, because why would they? They're not going to text scrape anymore, because why would they? Like those were means to an end, right? Like you need to get the information. It's only available through those interfaces, so you do what you need to do to get that information. Yeah. So I'd say we've come a long way in a relatively short period, would be my answer.
Next up, OpenConfig.
Yay, we got there. All right, I don't think this will take too long, because Obviously there's a lot of debate around OpenConfig and cadence and trying to drive this through a community versus having vendor provided augmentations. And what I really liked when I was reading up on OpenConfig just recently, obviously we all know of OpenConfig, right? We all know what it was trying to achieve, but the approach they've taken.
I'm going to interrupt you. Let's just rehash very quickly what it's trying to achieve. So you have this this world we've been talking about where vendor or non-network operating systems are now trying to model their data using Yang, but obviously every vendor has got their own data models. So if you are in an environment when you want to deploy multiple vendors or you want to swap vendors in and out, as part of your automation tool set, you're going to have to go and ingest new Yang models and then thus new code and thus new monitoring tools that have to monitor new paths and so on and so forth. What OpenConfig tries to achieve is a unified data model across multi-vendors.
Exactly.
Right.
Yep.
All right. Go ahead.
Yep.
Go ahead.
So
resume.
I'm going to wind back to SNMP for a second here, right? Because I do think this is relevant.
Let's start over.
Yeah, just wind back to the start.
Exactly. We'll start right back up.
So the way SNMP started, there was a bunch of kind of IETF driven MIBs, right? Like IFMIB is kind of the common one that a lot of people use, the sysmibs, of course. And these were kind of like at least a base set. The terminology that I saw within OpenConfig was the minimum operationally viable set of data nodes. Okay, so that's kind of like what OpenConfig was trying to achieve. It's what SNMP tried to achieve as well, because, or what the MIB infrastructure tried to achieve, in that here's a foundation, here's all the things that are absolutely common across everybody who's going to implement SNMP. And of course, those evolved over time, but they didn't evolve that quickly, right? And this is what led vendors to go, okay, well, let's say we're trying to do an EVPN implementation for a customer and I'm driving towards a release next year. I'm not going to wait for the industry to figure out what modeling, an EVPN service looks like, because, I've got deadlines I need to hit, in which case I'm going to go and figure out what that looks like myself. In SNMP's case, you have kind of vendor proprietary MIBs, which they can add on, they distribute as part of their operating system. That same concept exists within Yang, right? And especially within OpenConfig, in that they try and hit that minimum operationally viable set of data nodes. And beyond that, they allow augmentations, right? Yang is kind of beautiful in allowing kind of a very elegant method to augment the tree, to change nodes that were already there, or to just add additional nodes, or to add constraints. I mean, it's very, very rich in that aspect. What I think OpenConfig, the controversy around all of these kind of open, unified data models is the cadence story. Like that's the only downside to this, at least in my mind, is the cadence story. In that, the same thing that applied to SNMP, where a vendor is trying to implement a feature and they're trying to do it to hit a timeline for a customer that is trying to differentiate themselves within their market segment. They're not going to wait for, the community, the industry, to figure out how to model it. Like, they're too busy building the feature, right? They just want to get the feature built. Yep. And I see that as being the potential risk to OpenConfig's future. Now, I think the approach they've taken is as good as you can take, which is, and we'll get a little bit into how they accept contributions now and kind of the barriers to entry, so to speak. Yeah. So like I said, they maintain this minimum viable operational data set. And I was thinking that this probably wouldn't be that rich. Like we have segment routing, we have SRT policy, we have BGP-LU, we have BGP flow spec. There's a lot of these kind of more modern technologies that we're now starting to adopt in our networks. And I was thinking that OpenConfig probably didn't have data models for those yet, right? And we were just going to do a repeat of SNMP. Yeah. I was wrong. I was flat out wrong. They actually have modeled a lot of this stuff already. I couldn't find anything I was searching for that didn't have an OpenConfig data model already. Now, those things have been around at least for a little while, right? We're not talking about like on the cusp here.
Yeah.
But I my impression of their cadence and the reality of their cadence were very misaligned, is what I would say.
Right.
What was your interpretation of OpenConfig?
Well, as in for you, just to clarify, the cadence was such that it's much better than you anticipated. Yeah.
Exactly. Yep.
Yeah. I actually don't think the biggest challenge for OpenConfig is the cadence, but more the adoption on your actual network operating system and that cadence. So even though the community may or the changes may have been accepted, you may have a new model you wanted to push into OpenConfig. It's been accepted. It's been put into the official OpenConfig Yang models. Getting that implemented by your vendor or your network operating system is, I think, the bigger challenge in implementing OpenConfig. And of course, OpenConfig came out from the folks at Google, so they have a bit of weight in trying to push their vendors to implement the model they want. But if you're not Google, or you're not someone with a lot of weight behind your voice, that becomes a bit more tricky, I think, right?
Yeah, for sure. And we have tried to solve this a little bit through the interface, right? Like one of the RPCs that you can call with GNMI is the capabilities RPC. Yeah. And the whole idea is that OpenConfig defines the schema and a bunch of different models for modeling different things within the operating system. But the real source of truth is the NOS itself and which models it implements, right?
Correct, yeah.
And GNMI allows you to query that. So you're not just blindly going, this NOS supports OpenConfig, so I'm going to try and do a set or a get against a node within the data model.
Yeah.
And you find out that it doesn't work.
No, capabilities gives you the way for you to verify what your NOS can or cannot do from a perspective.
Yeah.
But the actual implementation of a change that's been made to OpenConfig onto an actual NOS is, to me, challenging.
Fair. And we did talk before around Utopia, where your CLI and your more northbound interfaces all follow the same schema, and everybody's speaking the same language, just with different transport and different encoding. I do see this as another challenge with OpenConfig, in that it very much is modeled as a machine model. And what I mean by that is, the word I would use is obtuse, honestly. Like if you're a human trying to navigate through context within a system that is modeling things using OpenConfig, and you want to look at an IP address on an interface, that's an effort. Like you're modeling, you're going through like either a config context or a state context or multiple config and multiple state contexts, and then you've got interfaces that have an interface list underneath and sub interfaces which have a sub interface list, and then you got IP addresses. I mean, it's madness.
But if you take a step back and think about why it was modeled that way, because the intent behind it was never to have a human to machine interface such as a CLI leverage these models, right? I mean, the intent was a machine to machine, and in that case, then that's fine, right? So I think ideally, utopian world is everything's modeled off of Yang. Your human to machine interface is the same, but as you said, you have maybe, I don't know if there's compromises in doing that. Like maybe the OpenConfig model is perfect for machine to machine. It's not so perfect for human to machine, like CLI type constructs based off of those models. But maybe if you did have something that was acceptable in both, you would have some compromises. I'm not sure.
Yeah. I mean, maybe. I like to think a machine just needs a programmatic way of interfacing, right? Understanding what it should send, and I guess more importantly, what it's expecting to receive, so that it can marshal or unmarshal that into a data structure. Outside of that, I don't think machines care too much about how things are modeled per se. Now, obviously, that's not true, because they do care at least a little bit. I think humans care more. So if you're going to design a data model, you should design it for humans and not design it for machines. Machines is kind of your fast path as far as I'm concerned. And I'm sure, there's experts out there that might disagree with me, but that's kind of my interpretation on this, is that Utopia is no translations, and that means you're just exposing data structures. Now, if we go like full blown Utopia, the only thing talking to the network is a machine, right?
Exactly. Which I think is what the driver was, or not the driver, but I should say, when they were building these models, that was kind of the method they were thinking of, and that the A would be no CLI, and you would never log into a box and look at it, or if you did, it would be very limited in what you could do, and it didn't need to be modeled off of the same Yang models. I don't know.
Yeah.
Otherwise, why would you do it this way, right?
Maybe that would have helped adoption, though.
Well, that's what I'm thinking now. But that's something that's another challenge, right? Because again, if you are living in a world where you still do a lot of work, a lot of troubleshooting using the CLI, which, let's be real, that is like the very large majority of people out there. If, I don't know what the percentage is, but it's got to be like 98% of the people out there still log into a CLI to troubleshoot the issue today. You do need to keep that into consideration. And if you have a way of modeling things using OpenConfig, but that doesn't line up with what you actually can do using CLI, or there's like a CLI, there's like like the state that's populated using OpenConfig is a separate CLI that's a shoot off of the main CLI. Yeah. It just adds these complexities, which could be causing, a slower adoption, a wider adoption in the industry, right? Until we get to the point where more and more and more of it is automated, more and more of it is and less of it is actually troubleshooting on box, and that differentiation between the models of the CLI and the models of your vendor may be using versus OpenConfig is less relevant.
Yeah, for sure. I would like to hear from kind of the architects of OpenConfig to see if this really was the motivation. I would like to live in utopia. Don't get me wrong. I've said that word so many times this podcast, right? Like I would love to live there.
It's the word of the day, apparently. Utopia.
It is. Yeah. And data modeling, of course. I think it was almost like a missed opportunity, unless there's significant reasons that they did things the way they did outside of, humans don't log in, so why would we try and optimize for them? Yeah, I think there was a way to have kind of that healthy middle ground, because like you said, what really happens when you have two different schemas trying to speak to like one application, right? There's a translation occurring somewhere, like there has to be. Right. And B, if there's no clean translations between the two data models, you end up with half-truths. You end up with like a piece of the information, but not the whole piece of the information.
Exactly.
And yeah, we've seen this with a bunch of NOSes where you configure something using kind of the vendor model per se. Yeah. And then you can't see that in the OpenConfig model at all. It just doesn't exist.
Or only part of vice versa. Exactly. Yeah, it's not exactly one-to-one mapping, right?
Yeah, and I think these are all like the hurdles. And not all of this is OpenConfig's fault, right? I think a lot of this is vendors don't have a lot of motivation outside of customers screaming to go and implement OpenConfig, really. Mm-hmm. Mm-hmm. They kind of, like I said, all those things I mentioned before around needing to build a feature and wanting to build it a certain way, and maybe you're building it on a certain chipset that doesn't support the way OpenConfig has modeled it. These are all real problems that, if you don't have that kind of, a holistic network where everything kind of looks and feels the same, maybe you can't even get there, right? But I don't know. Like I said, I do think we are at that kind of inflection point now where we know Google is pushing OpenConfig. There's a bunch of very, very large service providers in North America, also in China, who are also kind of pushing vendors to implement OpenConfig. So it will happen. I think the issue is going to be outside of those kind of tier ones, as we call them. I just can't imagine using CLI and having the underlying data structure being OpenConfig, unless we've gone away from that kind of the desired state where your CLI and your northbound interface kind of look and feel the same. If you ignore that idea, then actually maybe this isn't a problem, because your show IP int brief could work against an OpenConfig data model. And I guess the idea is that you're not screen scraping your CLI anyway. You still have the OpenConfig model there.
Yeah. Yeah. Hopefully you're not. If you have the models, hopefully you're not screen scraping.
Hopefully.
Yeah. It's no guarantee, but yeah, hopefully.
Yeah. Yeah. So yeah, I guess if you ignore that fact and you just go, okay, CLI is for humans, doesn't need to be modeled at all, because people aren't going to text scrape it. The same problem we have today with CLI show commands. Let's not try and solve for that. And maybe that was the decision they made.
Maybe we need to try and get Anis and or Rob or anyone else from the OpenConfig crew to come on and talk to us about it.
Yeah, I'd be interested, right?
So if your name is Rob Shakir and you're listening to this right now, please reach out. We'd love to have you on to talk about this.
Yeah, and he's very passionate about it. I'm sure he'd want to defend some of the decisions they made. And again, we're not throwing stones, right? I think
no, I don't think so.
We're assuming certain goals, and maybe those goals are wrong, right? Like in my mind, the utopia, your CLI and your GNMI, your netconf, all of that from a modeling perspective looks the same. So when you're in your CLI and you're navigating around, you're really navigating around the model. And that certainly helps from an automation perspective, because, if you're trying to figure out how to automate something, you shouldn't be doing this anyway, because you can compile the Yang models, but we'll put that aside for a second. You can kind of go and look at how data structures look in real time in the system using the CLI. So I think there's a lot of benefits you get from having your CLI and your northbound interface kind of hit the same data structures underneath, and have those data structures look the same in both. But maybe I'm wrong. Maybe we're both wrong.
Maybe you're wrong. That would never happen, Bruce. Let's be real.
As long as we don't bring guests on, we're all good.
Exactly.
It's just a monologue,
It's a nice little echo chamber. You and I, we're both right. No one can say otherwise.
Okay, I do want to talk a little bit around the contributions to OpenConfig, because I found this kind of interesting.
Okay, go ahead.
Maybe this can be how we finish.
Sure.
So obviously the whole OpenConfig schema looks very, very consistent, right? How they model everything's across different, models, whether it be network instance or BGP, all look very, very consistent. How how the enumerators look, how identity rifts look, everything is very, very consistent. So that, of course, is the first hurdle, in that you need to write a model that conforms to kind of the consistent look and feel that OpenConfig models have, which is good. I think that's no complaints there. Makes sense to me.
Right.
The other thing that I thought was interesting is when you're implementing a feature and you want to define a model for an OpenConfig, you need to have at least 2 vendors that are building that feature. And now, I wasn't sure if this meant that they both had to agree on the data modeling of that feature, but at the very least, the terminology used was that they both have to have implemented the feature, like past tense. So this kind of confirms that you're not, it means you're not going to get any kind of random leaks within the model.
Yeah, exactly.
Yeah. So
it's kind of like a quick way to, you're bypassing the RFC process, which takes astronomically long.
Takes time.
Exactly. But at the same time, you're still putting a check in place that you're not getting a single vendor driving a bunch of their own proprietary features and models. You still have to have a check there where if this vendor implements it, you need another vendor to implement it. Therefore, it's open enough that there's 2 implementations of the same feature, which can now be modeled in OpenConfig. Which actually think that's a great way of doing it.
I agree.
It's probably the fastest way of doing
simple,
it.
Right?
Yeah. It's the fastest way of doing it, except for now you have to have 2 vendors agree on a feature, which the RFC tries to solve. I mean, the IETF tries to solve, right? So I don't know how this works in practice, but in theory, this sounds like a great idea.
Yeah, and so the idea, the whole way it works is basically it's all code driven, right? The discussion happens after there's like a pull request sent. So you basically define what the data model should look like. I guess you have 2 vendors agree that that's what the data model should look like. You submit it, submit like a pull request to the main OpenConfig repo. There is apparently a working group like in the ITF.
Okay, all right.
That meets once a week, and they kind of discuss any of the pull requests, see if they're viable for pulling in. And if you get accepted, then you go into a private repo that anybody who's kind of active in the OpenConfig community has access to. And eventually that will get kind of upstreamed into the main public repo. So
seems all rather reasonable.
That was my exact interpretation of this was, this seems to make sense.
Seems now, the only thing is, I mean, vendors, what if I was using Sonic? Now, Sonic doesn't use much in terms of Yang for modeling. But let's assume that Sonic used Yang extensively in their modeling their applications and their data. That's not a vendor. So I guess as a operator, and I'm making changes to Sonic, and I want to make changes to OpenConfig to be able to leverage that on my application inside Sonic. Would I be considered a vendor?
Ooh.
Would I have a voice? Or now do I need Arista or Cisco or Nokia or Juniper or whoever to go and implement it? Like, how does that?
I mean, certainly
if
it
there's
sounds
two
like these
operators-
rules were designed with the...
For vendors, I know. The
Yeah.
traditional vendor in mind. Yeah,
Yeah,
which is
yeah,
fair.
exactly.
Which is very fair because there's something like Sonic that hasn't existed for very long. The fact that it's gaining some traction is very recent. And not only that, but it's not even modeled in Yang, so irrelevant from most of my perspective. but anyway, you get the idea. I was just wondering if, do two operators using the same operating system count as a vendor? As two
Yeah,
separate
I mean, like,
vendors?
so what happens if I like go and define, because, you and I both work for a vendor, so we go and define in our operating system a data model for something, and then we just go submit that to Sonic too.
Sonic,
Bada
exactly.
bing, two vendors,
Bang.
baby.
Loophole.
We just broke
Didn't think
the
of that
system,
now,
dude.
did you? We
Yep.
just broke OpenConfig. We
Oh,
apologize
dear.
for
No,
all those who are going to
I really
go
don't
in.
know. I don't know. That's a good question.
Yeah.
All right. I don't have anything else to talk about data modeling. I think we covered a lot. We talked for longer than I thought we would, but
These tend to go for much longer than we anticipate.
they do. I hope the audience appreciates that and doesn't hate us too much.
Hopefully. I hope so. Hopefully.
All right. I think we can wrap up then.
Let's do that.
All right. So I guess thanks for listening if you made it this far. I hope this was interesting. We tried to make it as interesting as possible. Everyone needs a history on SNMP, right?
Yeah, exactly. And everybody should reply to us on Twitter or LinkedIn or YouTube or wherever you heard and listened to this from, and let us know how what you think about it. We'd really appreciate it.
Absolutely. Yep. Alrighty. Let's cue the outro. Thanks for listening,
Have
and
a
we
good
will
one.
catch you in the next one.
Bye-bye.
Hey everyone. Thanks again for tuning in. As always, please do let us know any feedback or criticisms you may have. We can be reached on Twitter, YouTube, or our website, ntwr.kn, where you'll find this episode and many others posted. For those of you on YouTube, if you liked the episode, please hit that thumbs up button. And if you didn't like the episode, feel free to hit the thumbs down button twice. On a side note, you know those cliche, "these are our opinions and not that of our employer" statements you hear all the time? Yeah, we unfortunately have to make one of those. The benefits of working in the industry we want to publicly have an opinion about. We've done our best to remove bias, but we're only human and we make mistakes just like you. Thanks again. We'll see you in the next one.